Up until now, we've been talking about momentum, how hard it is to stop an object. On the second day of class, we did a problem where the object was falling and we had to find the momentum as it struck the ground. We've done a few of those since then. We talked about, at that time, the idea of momentum sometimes changing. Right? Momentum exists at a specific moment in time. When we're calculating momentum, we need to know the velocity then or now, not the change in velocity in between. Okay, momentum exists at one moment in time. But that momentum can change from one moment in time to the next. Well, how do we quantify that? How do we quantify that change in momentum that we've seen in some of the problems that we've done, but that we haven't dealt with to this point? Well, that concept is going to be called impulse. Impulse is defined as the change in momentum experienced by an object. The momentum gained or the momentum lost by the object. The rock that falls, or the penny, Jake, that falls from the top of the CN Tower down to the ground gains momentum. Its momentum when it started was 0. Its momentum when it hits the ground is something. The change in momentum is a positive value. It's gained momentum as it's fallen down towards the ground. It's experienced an impulse. When you throw the ball up into the air and it slows down, and stops, it loses momentum. It also experiences an impulse, a negative change in momentum. Because it's the change in momentum, and momentum is a vector quantity, then impulse is also a vector quantity. There is a direction associated with it. It matters whether that penny is falling down from the top of the CN Tower or being thrown upwards towards the top of the CN Tower. All right, well, if we're going to quantify it, we need an equation, right? Because that's what we mean by quantify. We're going to go back to Newton's second law, though, for a second, something that you learned about in Physics 20. Remember Newton's second law, Physics 20, F is equal to m times A. That's not new. We did that probably the second month of Physics 20. But A is also equal to delta V over delta T. So I can replace that if I want with delta V over delta T. Is that okay? Is that a legitimate thing to do there? Am I allowed to replace delta V over delta T for A? Okay. Let's rearrange a little bit, just a little bit. Let's take the T up by multiplying. It becomes F times T is equal to m times delta V. What's m times V equal to? Listen carefully. Not what's m times delta V. What's m times V equal to? Momentum at a specific moment in time. So what do you think m times delta V is equal to? If mv is momentum, then m times change in V would be the change in momentum, or the impulse, yeah. So this is impulse. Impulse is m times delta V. But look what else impulse is equal to. Force times time. If we take a step back from this for a second, that should make sense to us. If you want to change the momentum of something, in other words, if you want something to speed up or slow down, if you want that penny, Jake, when you drop it from the top of the CN Tower to speed up, or if you want that car that's coming to a stop sign to slow down, okay, if you want it to change momentum, then you need to do something to it. You need to apply a force, and you need to apply that force for a certain period of time. The bigger the force, the bigger effect you'll have on the object. You apply a bigger force on a car when it's coming to a stop, you'll stop it quicker. You apply that force for more time, okay, you're going to stop that car more effectively. So both force and time affect not momentum at one moment, but how much the momentum changes by. In other words, if momentum is affected by m and v, the mass and velocity, impulse, the change in momentum, is affected by how hard you push it and how long you push it for. Does that make sense? All right. This is an equation, by the way, which does appear on your data sheet, almost. Everybody take a look at your data sheet right now. In front of your binders right now. Take a look at that data sheet. See if you can find that somewhere. I don't see that exactly the way that I have that written. It's close, but not exactly the way I have it written. I see F times delta T is equal to M times delta V, but I don't see the word impulse beside it. Okay. Nowhere does it actually say the word impulse. Nowhere does it even actually have the symbol for impulse. So you've got to remember that F times delta T equals M times delta V is the impulse equation, even though it doesn't really tell you that like it does for most equations. Make sense? I don't think that's crazy hard to remember, but it is something that we've got to remember, not just read off of our data sheet. If I ask you to find impulse, well, you can calculate it by saying M times delta V or F times delta T. Sometimes you might use these two things together. Okay? Basically, what I'd like to do is change the equation as it appears on our data sheet from this to this, because I think it makes it a little bit more versatile. All right. When are we going to use impulse to solve a problem? Well, Monday. We use impulse to solve a problem on Monday. But when are we going to use it on Monday to solve a problem? When you're asked for impulse? That's the easy one, right? Of course. If you're asked for impulse, you're going to use impulse. If you're asked for speed, you're going to use a speed equation. If you're asked for force, you're going to use a force equation. If you're asked for impulse, you're going to use impulse. Okay, that's the easy one. When a problem mentions a change in momentum, how much momentum is gained by the penny as it falls from the top of the CN tower to the ground? How much momentum is lost by the penny when it hits the ground? What's the change in momentum of the train as it came to a stop? If it mentions change in momentum, momentum gain, momentum loss, it doesn't actually have to say the word impulse. We're still going to use impulse. And finally, and this will be the last thing that we do here today. Finally. And this is the really weird one. If we see a force and a time in the same problem, in other words, the question may not actually say impulse. In other words, the question may not actually even say momentum. It may appear to have nothing to do with momentum or impulse. If you see a force and a time in the same question, we can do impulse. Why? Because when a force acts over a time, you're going to cause that object to speed up or slow down. In other words, when you apply a force over a certain time, you're going to change the momentum. That will be an impulse. So I want you to memorize these like crazy, okay? Because whenever you see any of these three things, I want you to do this. It's always valid for these three things. Got it? All right, we'll wrap it up there for today.